Sometimes you hear that you have to work out constantly or you will pass out and possibly die in space. Not true. Living on a spaceship is the most lazy existence you can imagine. You're weightless. You do not have to lift a finger. You don't have to hold your head up. Your heart doesn't have to lift your blood against gravity. You can be the laziest person in the universe in space. But eventually you need to come back to Earth. And if you don't exercise for your whole 6 months in space, you'll sort of turn into a jellyfish. So we do exercise 2 hours a day on a spaceship. We have a resistive machine, we have a unicycle, and we have a treadmill where elastics hold us down just to keep our bodies strong enough and our bones dense enough so when we get home, we don't just fall over like a puddle. But you don't need to work out all the time. So there's a lot of word out there that if you go incredibly fast, like the speed of light, if you could travel at the speed of light, that you won't age. And despite thousands of years going by, you'll stay the same, but everybody that you know will die. That's not really true. Einstein called it relativity because what he meant was your aging will be different relative to people's aging on Earth. You'll still age. Time will still pass for you, but people on Earth will age at a different rate. So that if you came back after going incredibly fast, you would have gotten older by the amount of time that it took for you to travel, but people on Earth would have aged much, much faster. They would have had a longer period of time because if you get going fast enough, your speed is sort of proportional to the time passing. So you'll still age, but you just age at a different rate than people back on Earth. Einstein did this cool thought experiment. Imagine if you were looking at a clock. The light from the clock is coming and hitting your eyeballs and telling you it's 12 o'clock. Well, imagine if you could move away from that clock at the speed of light. It would only say 12 o'clock because that light and you would be moving away from the clock at the same speed. So for you, it would look like it was always 12 o'clock forever. You'd still be getting older, but that clock would always look like it was the same time. The people on Earth were continuing to live. They're not aware of you going the speed of light. So you can see that the time for you, because of your speed, is relatively different than the time for the people on Earth. It's a really unusual thing to try and grasp in your head. In so many movies, you see that the only way that they survive interstellar travel from one star to another is to freeze yourself into cryo-sleep. We don't know how to do that. Right now, when you freeze water, which is what we're mostly made of, our blood and everything, it goes into crystals. It turns into ice crystals. And if you allow the beautiful, delicate nature of your human body to expand into ice crystals, it'll destroy the structure of you. It'll kill you. You know, frostbite destroys it so that you get gangrene in your hand. You'd end up with entirely destroyed bodies. So right now, we do not know how to successfully freeze a human body so that it is not going to be permanently destroyed. Maybe we'll figure it out someday. But all of those movies that rely on freezing the crew, we don't know how to do that. It's not real. You've probably read somewhere on the internet that if you go to the space station, your body will get taller, sort of expand, and it'll be painful, and you're going to be taller forever, an irreversible experience. And it's not really true. As I'm standing here talking right now, gravity is pushing me down towards the floor. Every single bone in my body and the little bit of gristle that's in between the bones, like each of the vertebrae of my back, every one has a little disc in between each of the bones, and even my hip bones and my knee bones. There's a little bit of a gap. Well, if there's no gravity pushing me down, then those gaps can all get a tiny bit bigger. If you stay in weightlessness for a few weeks, in fact, your body just sort of stretches because the gap between each of the bones gets a little bigger. And in my case, I got about that much taller. But you aren't really taller, you're just sort of temporarily longer. But it's not permanent. As soon as you get home and gravity starts doing its work on you and grinding you down, everything squishes back down to its launch. So you may be for a little while a little bit taller in space, and it may hurt your back a little because everything's sort of getting pulled tight. Some people have back pain in space as a result, but it's not really growing. It's just sort of stretching to your natural maximum that you're going to get squished back again as soon as you get home. If you do get maybe that much longer after you've been in space for a few weeks, think what your pants would be like. You know, they're gonna be high above your ankle. And if you put on a spacesuit, who custom fit the spacesuit to the size of your body? But we know it's going to happen, so we actually plan in advance. We fit our spacesuits knowing that the astronauts are going to be a little bit taller when they're in space, or at least their bodies are going to be a little bit stretched. And even the seat seat that protects us when we come back to Earth, the crash seat, so that when we hit the ground it protects us properly, we allow for the fact that our backbones are going to be slightly longer when we're up there. But your clothes, you don't really know how they fit because you're floating around weightless. Your shirt is always floating around your body. So you never really have a sense up there how well your clothes fit, just because there's no gravity to pull them down and look and see how well they're fitting on your body. It's more like they're just floating next to you.